Okay, so welcome back to the fourth video. In this video, we'll be talking about something called as a recursion, which is basically a function calling itself inside its own body. This might sound a bit weird, but when we try to code it, it will all make sense. Let's actually try to calculate the factorial of a given number. First, we'll do it without recursion, and then I'll tell you how recursion simplifies whatever we are trying to achieve. So let's calculate the factorial right now. Factorial is basically the number is multiplied with its number minus 1 till we reach 1. So let's say we have to calculate the factorial of 5. So the factorial of 5 will be 5 into 4 into 3 into 2 into 1. Right. So since we have to repeat the statements multiple times, we'll need a loop. So let's take a temporary variable for storing the factorial, and we'll take a loop variable, let's say I. So we'll start the loop with the given number, which is x, and we'll go on till the number is equal to 1 with decrementing 1 every time. And now we can simply multiply this value to f every single time, f into I, so that we get the desired output, right? So let's say we have 3 here, so we'll first start with I is equal to 3. So this will become 3 because 1 into 3 will be 3. The next time it will become 3 into 2, and the next time it will become 3 into 2 into 1, right? So that is, the loop will run properly as we want it to. Now let's return the value of f and try to print it in the main statement. So we'll say printf the factorial of say 5 is %d, and we'll call the function here directly. We'll say factorial of 5. Again, it is not necessary that you pass only variables here. You can even pass constant values to the arguments, not an issue. So let's run this code and see if we get the required output or not. The factorial of 5 should come out 120, which it does. You can check it out if you want to, but it is correct. Now let's try doing the same piece of code using recursion. So in this case, we'll not need a loop variable. We need another temporary for showing the factorial, obviously. And here, if x is equal to 1, we'll simply return 1 because the factorial of 1 is 1 and we can't help it. The next step is else. If it is not 1, we need to decrement it by 1, right? But since we are not using a loop here, we want to call the function again. So we'll say f is equal to x into factorial of x minus 1. Right, so let me explain what this statement will actually do. Suppose we have 3, so the f value is 1 initially, x will be 3, so this condition will fail, so it will come to the else part. Now here it will be 3 into factorial of 2. Now it will again go and call this function back again. It will try to calculate the factorial of 2, but since it is again not 1, it will again go to the else block. Now the value of f will become x is 2 now, so it will become 3 into 2 into factorial of 1, and similarly it will go on till we reach 1, right? Because when it reaches 1, the x equal to 1 will be satisfied and the function will return the value of 1. And after we have calculated it, we need to return the value of f. So that's what we'll do. And again, let's try doing that. So we should get the same output as the previous one. So there we go, we get the exact same output 120, which means that the code is working fine. So this statement uses the recursion concept because the function is being called in its own body, right? A function calling itself in its own body. Hope you get the definition now. So recursion is basically another way of repeating a given piece of code without a loop, right? We are not using any loops here. We are simply calling the function again and again until and unless we reach our deadline condition, right? So that is what the concept of recursion is. So go ahead, try it out, and I'll see you guys in the next one.